Hi everyone, I'm Tia Charis, your physics teacher in Senior 6. Now this lesson is going to focus on application of the case where we are having two open ends, another one where we have one closed end. So a particular organ pipe has a length of 72 centimeters and it is open at both ends. Assume that the speed of sound in air is 340 meters per second. What is the wavelength of the fundamental in this pipe? B. If one end is now covered, what does it mean? If it is now covered, to mean that is closed at one end. Wow, very interesting. Don't you see that it is going to combine the first case and the second case? Great. If one end is now covered, what are the wavelength and the frequency of the fundamental? Remember, for both cases we have the fundamental, but we have the first harmonic, the second harmonic, the third harmonic, and so on and so forth. Now, for this case where we have open, do you remember that the wavelength for A the wavelength for the fundamental, let's start by V is equal to wavelength times the frequency, okay, to mean that the wavelength will be equal to V over the frequency. But do you know the length? But you have the speed and you have the length. And remember, the wavelength for this case, the length is equal to wavelength divided by, it was open at both ends, that divided by 4. To mean 2 times the length is equal to wavelength. So far we know the length, which was equal to 72 centimeters. Now, so if the length is equal to wavelength divided by 2, cross multiplication, 2 times the length is equal to the wavelength. That is 2 times 72 centimeters. That is the wavelength, to mean the wavelength is equal to 144 centimeters. Remember, in physics, it is very necessary to change into SI units. So the wavelength will be equal to 1.44 meters. Wow, great. Now let us go to the second one. If one end is now covered, what does it mean? We mean that at one end it is closed, then another one is open. For this case, remember, that was A, then B, the length is equal to wavelength by 4. Now 4 times the length is equal to the wavelength. Let us first find the wavelength. So wavelength is equal to 4 length. Now the length still is the same, 72 centimeters. Now the wavelength is equal to 4 times 72 centimeters. So wavelength will be equal to 288 centimeters, which is equal to 2.88 meters. So far now we have the length. Don't you remember the formula which is combining the frequency, the speed, and the wavelength? Let us use it. You know that speed was equal to wavelength times the frequency, and they asked us to find the frequency. That's very simple. That the frequency will be equal to the speed divided by the wavelength. So the frequency will be equal to the speed. The speed was equal to 340 meters per second, then divided by the wavelength, 2.88 meters. So when we are simplifying, it is very clear that meter will go, then remain by 1/2. Remember, 1/period is equal to the frequency. So the SI unit of frequency is hertz. So now we are able to understand if I have an open ends pipe, if I have a closed open pipe, to mean it is closed at one end and open at another end. So that's the case where we are having this question on B. Wow. Now, could we introduce at least when the pipe is closed, but I'm wondering, shall we have at least the sound? For this case where we have an open ends pipe, let's give you an example. Just if you are taking a small jerrycan like this, okay? If you have like this, don't you see that here it is open, here it is closed? If it is a pipe, don't you see that it is producing the sound? You may ask yourself, how this sound is produced? It is very simple, because if you have this, you are applying some molecules of air, and when they are entering there, they are vibrating. Through that vibration, they produce sound waves. So this is a simple case where we have an open pipe. If in this pipe, then here it is closed. That's the reason why when you are trying to whistle with a bottle of soda, you can hear that sound. So that's very interesting. Please like physics, because this is real life. Don't complicate things, because sound waves we are hearing everywhere. So thank you very much for understanding this application, how we can apply for open end pipe and both ends they are open. So it's a matter of knowing the other formula, general formulas. Do you remember where I wrote? Please, there are just two formulas to understand, don't cram them. So if you want more, please visit our website www.ubumenyi.net, or subscribe on our YouTube channel, which is Ikaramu TV. Subscribe and like our videos. You will understand more, because remember we're on production of sound waves, and we started by standing waves or stationary waves, where we have these two examples, and I request you to understand at the other general two formulas, then follow the examples that we produced, then you will understand very well how to apply them. I love you. Ciao, ciao. Senior 6 students. Thank you.